Welcome to Math in a Box with Susan Johnsey. I'm going to begin with some trig identities. I've put them in a blue box up here. The sine of a sum and the cosine of a sum is the sum of two angles. Now I'm going to change this slightly. We like to change this to the same two angles sometimes. So I'm going to write the sine of A plus A. Rather than use two angles, I'm going to use the same angle. Sine of A plus A would of course change to the sine of 2A. So this formula that I'm about to develop for you is called a double angle formula. Double angle formula for the sine. We'll also find one also for the cosine and the tangent. But let's see what we can do with this using the identity that I have written over here on the right. The sine of a sum of two angles is the sine of the first angle times the cosine of the second one. Add that to the sine of the second one times the cosine of the first. Alright, let's do that over here. That will become the sine of A times the cosine of A, because our first and second angles are both A. Now we put the plus sign, and now we'll have the sine of A cosine of A. Now if you're not sure what I'm doing, then you probably need to go back to the lesson where these two identities are taught. The two identities in the blue box, I've already used these for two other lessons. So if you're not sure what's going on, you need to go back to a prior lesson. The sine of A times the cosine of A. That's both of these terms. So that means we have two of those. So we have 2 sine of A cosine of A. And that is a double angle formula for the sine function. Now let me give you an example of how we can use this. If we know that the sine of an angle A is, say, 4/5, and we also know that the angle A is in the first quadrant, which means it's between 0 and 90. You could write it that way. A is less than 90, but it's greater than or equal to 0 degrees. Then my question is, find the sine of twice that angle, sine of 2A. The sine of 2A. Well, using the identity that we developed above, right here, the sine of 2A equals 2 times the sine of A cosine of A. Now as we start to substitute this in, you'll notice that I only gave you the sine of the angle A. So that's this part here. We do not know the cosine of A. So we're going to have to stop and decide what that is. Find it. We can do that either by drawing a triangle, or in the correct quadrant, of course, or you can use identities. You may know this identity. I hope that you do. The sine squared of A plus the cosine squared of A, that's the same angle in both of those, equals 1. If you know the sine, you can use this identity. It's called one of the Pythagorean identities to find the cosine. Or you can draw the angle. Here's the triangle, reference triangle. Here's the angle that we're referring to, the A, and the sine is the opposite side divided by the hypotenuse. So the 4 is the opposite side, the hypotenuse is the 5. If you use Pythagorean's theorem, you will find that this side here, the adjacent side, is 3. So we can find that the cosine of angle A is, the cosine is the adjacent side divided by the hypotenuse. That's 3/5. It is shorter, and I think quicker, to use the Pythagorean identity here. So I'll go ahead and show you that. Sine squared A was 4/5, so I guess I could just put 4/5 here. Change that. 4/5 squared plus the cosine squared of A is a 1. If we square 4/5, we will have 16 over 25 plus the cosine squared of A equals 1. Now to solve, we subtract 16 25ths from both sides, and you will have 9 25ths when you subtract that from the 1. And then we're going to take the square root, because we have cosine squared. I know it's a little hard, but there is a square there. And then we have to think about this. We are in the first quadrant. The cosine is positive there, so when you take square roots, you normally have to put a plus and a minus, but we do not need the negative because we are in the first quadrant, and that would be 3/5. And you can see we have the 3/5 both ways. I'm not sure which way you would prefer. You can do it either way. You can use the angle, the triangle, or you can use the identity. Alright, so now we have 2 times the sine of A, that was 4/5, so 2 times 4/5, and we found that the cosine was 3/5. Now this angle was in the first quadrant, so both of these are positive. If you have an angle that's not in the first quadrant, then you'll have to be sure that you have your positive and negatives correct. Alright, when we simplify this, we will have what? 24 over 25. So the sine of double of that angle, the angle that we were talking about in the first quadrant, if it were double, its sine would be 24 over 25. Another way that we can use the double angle formula for the sine is on a problem such as this. If we have 2 times the cosine of, not cosine, I meant the sine, 2 times the sine of 30 degrees times the cosine of 30 degrees. If you'll look at this carefully and notice it matches up exactly, the identity up here. It's 2 times the sine of A cosine of A. That is the same angle in both places. Then we can use the identity, the double angle identity. This would be equal to the sine of 2 times the angle. Well, our angle is 30. So this becomes the sine of 60 degrees. And the sine of 60 degrees is square root of 3 over 2. Square root of 3 divided by 2. Now occasionally they might try to fool you, and they might write it backwards. They could put 2 and then the cosine, say, of 30 degrees times the sine of 30 degrees, but that's really the same problem. You know, to move these around, that's the commutative property of numbers. So it will give you the same answer that you have there. I have written the double angle formulas over here in this box, new box. The sine of a double angle, the cosine of a double angle, and the tangent of a double angle. Now you'll notice that the cosine of a double angle has actually 3 different formulas that can be used. There's one formula that uses the cosine squared in it, and another that uses the sine, and then there's a third one that uses the cosine and the sine. Now they are all each squared. These change just a little bit each time, so carefully look at them. But that's the cosine of a double angle. Has 3 identities. The tangent of a double angle is a fraction. Let's take 2 times the sine of b over 2 times the cosine of b over 2. Now notice here that the angle is b over 2, or half of a b. That is the double angle formula. Even though I don't have an a, plain a, I have a b over 2. Both of my a's here have essentially been replaced with b divided by 2. So that means I will go over here in the double angle part of it and change the A to B over 2. B divided by 2. So our angle for this problem, the A that I have written for your identities, in the identities became B over 2, or half of a B. 2 times half of a B is, of course, a whole B. So this becomes the sine of B. Alright, try this one out. Which identity is this? 2 cosine squared of 45 degrees minus 1. Which identity is this one? Well, I hope you see that it's the cosine of a double angle. It's the first one that I wrote for you. So it's the cosine of 2 times the 45 degrees. 2 times 45 is 90. What is the cosine of 90? 0. Okay. Two times the sine of 35 degrees times the cosine of 35 degrees. Do you recognize that identity? So knowing your identities is very important. If you don't know something is an identity, if you don't realize that it is one, you're not going to know how to simplify these expressions. This is the first one. It's the double angle, the sine of a double angle. So this becomes the sine of 2 times 35. The sine of 35, 2 times 35, excuse me, is the sine of 70. Now the sine of 70 is not one that we know automatically. It's not one we've memorized. That's a good answer. Or if they wanted to know the value, if the question says to find the actual value, then you'll have to use your calculator. But if it just says to simplify, then the simplified answer would be this. But to find the actual value, you would need the calculator since we do not know the sine of 70. Alright, let's look at another one. The cosine squared of 4m minus the sine squared of 4m. Do you recognize that one? That's the third identity that I have listed up here for the cosine of a double angle. Now notice the A in this was replaced with 4m. So our angle cosine squared A is now cosine squared 4m. So our angle is 4m. This becomes the cosine of a double angle. Our angle is 4m. So this equals the cosine of 8m. These are just some of the different types of problems that you can see with using the double angles identities in Trig. There are many other ways to use them. One other way is if I ask you to find, let's say we want to find the cosine of 2a, and I'm going to tell you that the tangent of a, not 2a, but the tangent of a is 1/2. And I'll also tell you that a is acute. Acute means it's less than 90 degrees. How would we find the cosine of 2a? Knowing the tangent. Well, if we look up here, the cosine of 2a, the three formulas that I have do not use the tangent. We're going to have to either find the sine or the cosine of a. So let's draw that. Acute angle, that would be in the first quadrant. Your first quadrant angle is here. That's angle A. Then drop it down and draw your right triangle. And then the tangent is the opposite side divided by the adjacent side. Or some people remember it as y over x. Your y side of your triangle is here. That's 1. And the adjacent here is the 2, or the x. Now use Pythagorean's theorem 2 squared plus 1 squared would give you 5, so this hypotenuse is the square root of 5. Alright, now what is the cosine then? The cosine of angle A would then be 2 over the square root of 5. And that would have to be rationalized normally. Let's go ahead and use the formula up here that uses the cosine squared. The cosine squared, it's 2 times the cosine squared of our angle A minus 1. Subtract 1. Now we know that cosine of A is 2 over the square root of 5. I need to square that. Well, that'll give me 4 over 5 minus the 1. And so we have 8/5, I hope you can still see this, minus 1. And to get a common denominator, our final answer would be 3/5. So the cosine of 2a is 3/5. I hope this has helped you understand how to use the double angle formulas for the sine, the cosine, and the tangent. This is Susan Johnsey with mathinabox.com. If you need help, you can email me at mathinabox@gmail.com. Thank you.